Okay, so this is something new for me. I am starting a stream and I'm going to give this a shot. I haven't done it before, so let's see how I go. This is a Shocktube, sort of Nonel Shocktube stream, I guess, and yeah, I'm going to do a few tie-ups. So let's just move that window over there, and I will put on this here. Excellent. Okay. All right. We're here, and I'm in this software, and I'm going to be using this product here, but you could use something else, I suppose. And I just want to show you a few tie-ups and that. So let's see where to start. I don't know. So I've done a couple of really simple tie-ups, essentially some first basics. So we'll load that in, and we've got this kind of tie-up here where we're just doing a 2567 echelon kind of blast here. It's only 10 holes in a row and 5 rows deep, and we can quite easily see the timing contours on that. Now you'll have to forgive me because I might stop and start, because I'm very much a serial tasker, and my brain takes time to think about the words my mouth has to do. So let's go with this sort of thing, and I just thought I'd show you how I use this particular program to do some really simple tie-up stuff, and we can do some pretty wild ones if you'd like, but just keep it simple for now. So I've got this echelon design here that I've already done. I've also done a traditional sort of flat V, what I'm calling a flat V, simply because this is quite a flat V. Obviously the faster you go along here, the flatter the V would be. The longer you go back here, the flatter the V would be. Certainly this is just very traditional old school Nonel timing. And here's another one that I prepared earlier as I was just getting my head around it all. And this offset one here is sort of just basically about minimizing the number of holes that will replicate through this area that will line up within an 8 millisecond window. So let's go with a blank one, shall we? So I'm going to close these, and we'll start off with a blank one. I'm going to go into let's see, shall we do a center lift? Let's do a center lift as an example, or I can show you, let's do the echelon one first up from start. Rightio. So first of all, we're hitting this new sort of thing and just selecting our setup for this blast. It's all pretty good. This generally never works for some reason, this bit here, but we'll just do type in here simple first shoot. Sorry about that. A little bit nervous here actually, considering, and you know, echelon. Oh, probably spelled that wrong. Okay, so first of all we just got this simple design up here, blank template here, and then we're going to select a pattern to create, and just we're going to go with a staggered because that's kind of traditional. I mean, we can do some square patterns or some other ones here, but just go with a staggered, and we're just going to leave the grouping on rows. Excuse me. Yep, and here we go. All right, Here we have a pattern. We're just going to turn on the timing path, the whole IDs and the delays, and we'll probably put in the construction line because it's quite useful to have the construction line on. And then I've already set up my timing delays for this application. However, you can do that simply by selecting this here and adding a new timing delay. Alright, first of all, let's give them a charge because they are not charged. And how do I know that they're not charged? Well, let's go with this and select the whole. And you can see here, there's no charges in it. And it's always good to charge something because some applications don't work without charging. Anyway, so we're going to here and look at this, upload the, check on this. Sorry, my bad. Select this, or show our whole loading model, and here I'm gonna I've got stemming. It's pretty simple. You can just add multiple decks if you wanted to do that, but I'm gonna stemming, aggregate. Let's just go aggregate there. And I don't like these. This is quite a large database. However, these are the ones I really like. Anfo is my main go-to. You would have heard all the words that people say, which is best bang for your buck. And that is really true. So here we have a little display of what our blast hole looks like, and just going to apply that. Okay, and then we will looking quite stupid now because I know how to do this, and a little bit there you go. So we've loaded the 50 holes. Close, and we just give a little tick. Yeah, they're all good, all loaded, and we know that they're loaded when we look over here and we can see in this hole inspector that all your holes are loaded. You'll notice we've got no delays on here because we haven't timed anything. So if we're just going to do the echelon, well, we could start from hole 1, and but that's what my example did. So let's just start from the other end, and we'll make this our first hole, and I guess we can pick something that people love to talk about on the internet whenever there's a blast. They go, oh, you should have used 17s and 42s, as if that's the golden timing sequence. However, each their own. Anyway, got this sort of thing here, and we'll just select this. So we've selected our 17. Oops, there you go. Done it wrong already, so we're going to edit this whole delay. Let's drop that down to 0 and go back here, drag it across. Alright, there you go. Stupidly, I have turned off the timing path tool. There you go, here we have it. Let's just crank the timing path numbers up so we can see the delays. Obviously upside down because this is like drawing in that particular manner. And here we go back with the 42. So it's pretty simple here, and you're just drawing off, it's taking that first delay off here, 17, and adding the 42 in it to make it 59. And we just keep going along here with echelons. And this is as simple as your timing will get on a non-electric or a Shocktube related blast. Obviously, something to note that Nonel was a proprietary name, and that's why a lot of companies can't use it, and they call it Shocktube or timing lines or all sorts of different names. Here, go back to the 17 and onto the 42s again, and back to the 17. And so we have our timing lines, which is what this particular program calls them, timing paths. And because it's mainly a it's mainly a electronic blasting program, and I'm using it to sort of like cheat Nonel for the example here, and we can hit into our analysis, turn on our contour lines. Here maybe we want to see that at 25 millisecond intervals, You can see that. You can turn on our relief and see what our relief is, and we can dial that down, or even, obviously it's all going to be the same color because it's very consistent. Obviously when you get a different position of a blast hole, then you'll see those relief factors disappear. And I haven't tried this before, but let's give this a go and move a couple of these holes in to see what sort of relief they get. Wonder if we can move it once it's, maybe it doesn't like it with the analysis on. Yeah, it's not going to let us move that at the moment, which is fine, unless I have some kind of issue over here. However, that's all good. So that's as simple as it's kind of very simple echelon timing, and then let's kind of consider doing a center V like I was talking before. Just going to do a center V timing, sort of like a center lift, beg my pardon. And so I'm just going to take this through here. Yeah, I think I will grab that. Yeah, and functions, and I'm going to clear the delays on that. Rightio. So now we have a missing information here. Very shallow, very narrow blast, so it's not got a lot of poles there. Okay, all right. So if we were to do a center lift, you know, for, let's say we're fully confined on the upper side and fully confined on the lower side, we can grab the 17s here. Let's say, since we've done it with 17s and 42s, we're going to do the same thing here. Now this will work out all right, actually, I think. So we will grab these holes up here, just dial them up that way. Right, 17s, and we will just select this hole and just edit this hole delay. We'll bring it back to 0 to see if our timing is working together. And yep, it all gets renumbered, so that's really excellent. And then on this side we're going to put in an offset, because everyone loves offsets. You always get asked, as an engineer, you always get asked by the shop buyer, where's the offsets on the shot? Well, offsets are important if you're at your limits and you need to separate your timing periods. But if you're not at your limits on charge amounts and sort of stuff for vibration or overpressure, then offsets are not as important as what people believe them to be. However, it is good practice. So we're going to run 25s off this top side, or actually let's use 67s. So it's important to note that if you use like a 25-42, if we had 25s and 42s going back, we'd be making 67. So putting in a 67 offset would defeat the purpose of separating the charges. So by using a 67 on a 17 and 42 offset, or a 17 and 42 construct, it works, right? So we're just going to go along here, and this is the time consuming bit. Don't know why we're always getting that. There you go. Probably because I was clicking on the blast hole. So if we go past the blast hole, I don't get that issue of the dialogue popping up. I tell you, this is probably going to be extremely boring to most people because I am pausing a lot and talking, and then you'll think this is quite odd going back to a 42 or longer delay. Well, you could just do one side at 67s if you prefer to do that, but let's say there was another row out here, then it would make sense. There would be consistency in our methodology at this point. It is, we are cheating this program to do this, so it is a little bit laborious. It's probably not as quick as what some people are used to with other applications, however, where it's all set up. And in this occasion we have got everything going good, radio. And let's just turn on the analysis and see our, and you can see here this timing. This is a very sharp V. I'm going to really lift that center out, make a technical free face, and then fire in either side with these offsets helping. And if we check out our relief, we would sort this out. Let's dial that back into 2 millisecond increments. See if there's, there you go, 1 millisecond increments of our timing. We can see right here that we've got very a much longer period of time. So in this section here we're firing in the 9 to 10 millisecond range, and in this section up here we're in the 13 to 14 millisecond range. So we've added 3 millisecond offsets in that. But you can see here, pretty cool. We're just doing some simple Nonel stuff. Now the key in my mind and my personal experience with timing is the more consistent your timing and your methodology around your timing, the more consistent your blast is going to be. And we also have to understand that what our aim of this blast is. So if this is to trench run and a ramp and it's waste, then we don't really care too much as to how uniformly the blast moves, as long as the blast is fragmented well and easily diggable. So you can see here this and you can see this bend in the timing, and you can also see in the contour lines this tightness. It's much tighter through here, which would indicate that it's a slower relief time. Pretty standard fare. And what we are considering with this sort of like center lift or a ramping sort of shot, where we're firing probably perhaps, depending on your personal feel about it and what your geology type is, like if it's heavily horizontally stratified, you may want to be firing from a deeper point first, and then using a lot of energy first to make, so you don't lose energy, and you apply lots of energy first off to break the horizontal stratigraphy. But if it's fairly uniform rock, you probably might want to, and it's just hard rock, then it doesn't really matter too much. You could probably fire from the shallow end first. Firing from a deeper end with horizontal rock often gets a slabbier result. But, as long as you have a kind of a justification for using the energy and it works at your particular site or the environment that you're using this method in. Anyway, moving on with my boring first stream. I am going to, let's do something different, right? Shall I save this one? I might save this one. All file, save as a traditional Shocktube, and we will call it send lift. There you go. And let's open up one of those older ones, and we'll use the offset one, because I really wanted to show this example with the offset, being in this area here. And this is application is primarily for Shocktube related blasts. And I will get this, I think it's this one that we had, yeah. So we've got a very traditional in the center, just split, half the shot goes in this way and half the shot goes in that way. So if we turn these directional arrows on, we can see, just move that out of the way, we can see these here. Lines of contour, and perpendicular to those lines of contour are the movement arrows, first movements, often called first movements. And I will bring this back on screen here. You can see this is duplicating decks. So we have a bit of stuff duplicating decks here. So holes are lining up, you know, and there's really no way of getting around this with non-electric unless an echelon is used. So when we look at a standard traditional center V, very flat, using, you know, a very standard timing construct, we see that we get this replication happening, this amplifying the energy essentially. So now we're making two holes fire at exactly the same time. Now that's that offset. So just depends on how many of those you want. In this case, we've got a good number here, 8, and let's just close that and look at the offset one and see what the difference is between these two here. So if we turn that on, you can see here we're just moving this initiation point, which is what I was getting at, just moving this initiation point from where were we, hole 6 I think, or hole 7, across to hole number 3. You can see that we've now reduced our blast down to a single hole firing. This is just standard fare. Now this doesn't change with non-electric, or this doesn't change with Nonel, it doesn't change with electronic, it doesn't change with electric firing. If you minimize your directional changes within the blast, you are going to minimize your replication. And I think this is pretty interesting. Well, this is a 1, but we can dial that up and see what our values are within 8 milliseconds. So within 8 milliseconds, even then we've got 4 decks, right? 4 decks firing. Sorry, there you go. I'm still new to this, so I've been talking about this, and I've got my picture down here over the top of it. So I will swap that to, there you go. So if we were to, let's try that and attach this to the, let's attach it in there. We will get rid of this hole inspector. We don't really need to know too much about that anymore. Alright, so here we have our decks firing, and we've got 4 decks if we have a delay window opened up. Rightio. So let's look at the other one that we were looking at, which is well, this is the one, this is the offset. And if we go over here and we've got our delay window here at 8, okay, we've got 8 decks firing. So just from that move, you can see a significant increase. Now these are so aligned and so replicating that at 1 millisecond there's still 8 decks, whereas when we go back to the offset here, we can see that this is single hole, essentially within a 1 millisecond hole window, or a dominant hole window, you could say. And I think this is a simple trick that people often forget, just moving it to within 3. If you go to 4, you're on the edge there. I think 4's the limit, and we can test that out. Let's test that out by, let's delete these holes here. All right, and we will delete, let's delete this one here. We want 2, yeah. And we'll get rid of that one, and we'll get rid of that one. Rightio. And then we will go back and we will design this section back in, and we're going to have a 17 offset here. So let's just, first of all, first point I should have done is edit this whole delay, whack it back down to 0. Okay, so now we're at 0. Grab that 17 and we're going to drag it across there. I am getting terrible at this, so let's just delete that. As I was trying to explain, this is not the most awesome. I understand why Why is this? Because we have already assigned delays to it. So I'm just going to grab these holes through here and clear out the delays so that I can clear delays. Yep. And I have to rebuild all those delay points. But that's okay. That's pretty quick fix. Let's go with these 17 here. So we've moved from a offset of 3 holes to an offset of IP being in at 4 holes. We're going to see the difference that makes to our timing construct using very traditional. And now you'll note that something that's very interesting is that I always, and I suggest you do as well, always offset the shorter offset with the 1. So short 1, long 2. So pretty easy. And that keeps your contour path or your aisle very uniformed. If you do it the other way, with a short on long and a long on short, you end up with a kink going back, and we can explore that in a little bit if you like. I don't know even who would be watching this at the moment, and that's okay because this is my first one and I haven't done this before, so I'm having a good time just talking. I've been thinking about it lots and haven't had the courage to get on the stream, but anyway, here we go. So we've done that. We've done the delay controls there on the timing paths for this particular example, and we've just moved that offset 1 across. And I'm going to share this. Well, let's look at that timing path there. So we should. What should we do with this to get that to work? Let's fire it through. Yeah. And delay window on. Okay. It seems that. Oh, there you go. Awesome. Great. So that is what happens. Let me just get the program up. So I will be right back. Okay, so I'm back. I've got my program back up again. Apologies for that. I'll just expand it out again. Okay, so surprisingly enough, this pretty much broke the program trying to ask it to do something. Here, I'm going to get rid of this warning section down here and the undo limit. Right, now what I believe has happened with that was that I needed to just click refresh. It didn't like on the optimization window, stupidly. Right, so what were we looking at? The offset echelon, and yep, that was great. And we got this analysis up. Get our little offset here. Yep. So interesting. I'm going to close that one because we're just talking about how our offsetting can affect a blast. And over here, I'll just get these delays here. There you go. Go through here, and what do we got? We have 4, we have one long, okay, through here. Radio. Okay, all right. Well, now we're back on the money. Pretty easy. And we said we were going to offset with a 17 through here, weren't we? So let's just do that. 17. Yeah. Now, didn't like that, did I? No, that's all right. We'll fix that in a second, and then we're going to hit with the 25s. And then the 67s. Again, short, short. Very, very good to remember that, especially because, you know, I'll show you the kink in a little bit, but we had a little malfunction there with the application, so we're back doing this. You know, I don't know who would be interested in this. This seems really boring to anybody watching, but hopefully, hopefully someone gets some value out of it. I'm going to edit this whole delay here, putting that as 0. Okay, and that recalculates, and then we're going to grab that 25 and go across this way. Here we go, we're going to have a little problem. So I'm going to edit this whole delay, so that's 25. That's a controlling whole delay, so that should retime everything before I do this 25 over here. Yeah. There you go. Okay, here we go. Rightio. So we've now got our delays. I'm going to move those off this thing. I'm going to refresh this, and we can see here that we're still at 4. So whole being moved in 4, and with a 25-67 and a 17 offset, doing a short long sort of arrangement. We through the aisle, through the timing aisle, we end up with a very similar, that in 1 millisecond window time frame we have no replication, which is awesome. So what happens if we were to move that across again? Well, let's do that. So let's do that again. So we're going to move it across once here. So we're going to move from 4 to 5. Yeah, 4 to 5. I think so. Yeah, 2. Yeah. We're going to clear those delays there. We will change this to a 25. And then we're going to put these delays back in. I'll bring those back on. Let's go with the 25 off here. Now it's had a little hissy fit. So let's see what happens if we edit this. I haven't done this before either, so this should be exciting to see. 0. Well, it did it. It did. It flipped that delay, that timing path. So that's really good. Quite useful actually. I'm finding this program actually a lot more functional than what I first thought it would be for this exercise. And so now we're going to run through here and do these 25s up here. And hopefully, fingers crossed, there are no program crashes. And I'm really quite impressed because I'm running this in parallels now on a Mac, so it's really quite speedy. I've had other programs that I've used in parallels that have really tanked, and not being able to use those. I know why you're using a Mac to begin with. Well, I did like them many years ago. Okay, so I'm going to move that across and refresh this, and now we can see, so at 5 So this is at 5, we are looking at an issue. So we're really, 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 really good at 4. And at 3. But at 5, we are terrible. What a stupid way to draw across. You're saying, why are you doing this? Well, to bore everybody, I suppose. So at 5, we are, oh, bang, crash. At 5, we are hitting replications in the 1 millisecond window. Just checking that that's 1 millisecond, correct. So we've got, end up with 4 decks firing at 1 millisecond at 5. So move it across one more, and I think we get, 6 or 8. 8. So you can see just by moving it back to 4 or 3 position, and I personally suggest you always do 3 unless you have some issue in your mind around startup and shutdown of shots and being a very narrow band on this corner, whether you think there's not going to be enough interaction to actually move the dirt out and you're going to be forcibly choking the blast. However, I think it's quite an interesting little revelation. Like if you're sitting around initiating at 3 or initiating at 4, you're going to reduce your replication. At 5, you're not. So quite interesting. And at 6, we get double. So if we load that traditional flat V, excuse me, we're at 6 and we get 8. So between this one at 5 being 4 and just moving with one more hole across, we get 8. It's a pretty quick way to minimize your maximum instantaneous hole charge, especially if you're looking at things and your model is a 1 millisecond model or a dominant hole model. Then this is a fairly significant issue. So I think we'll save that one. Which will we go? Maybe I'll save that one. I'm going to call it an offset, but I'm going to call it offset. We're going to call it IP5, IP 5th, maybe. Yeah, IP 5th hole. Quite interesting, isn't it? Well, so I wonder what else we can do with non-electric or Shocktube timing. We can do lots of different things. So let us clear out oh, there you go. Stupidly, I have deleted a hole. So I'm going to undo that. Delete that. Something to be careful with this program. If you've selected a hole, when you have left it selected, you'll be not very aware that that's going to break everything. Alright, so our next one we can do kind of like for like. Shall we do like for likes sort of thing? So might get, yeah, let's do like for likes, just to give that message across what is the same and what is different, because I think this is something that's also missed with first-time engineers or people who are starting out in blasting. So we will select this and we will definitely clear the delays on that. And so the like for like I think we're going to do is we're going to grab the traditional Shocktube echelon. We're going to do a like for like. Now this is important. I think personally I find this very important concept to grasp is what is the same and what is the difference between something. And we're going to do some pretty extreme ones. I think we should do some extreme ones. All right, and hopefully this will support us. So this is a 2567 timing construct, what I would call, and it's a following the rules of thumb, which is 2 to 5 milliseconds on spacing and 5 to 15 milliseconds, probably upwards of 20 if you really want, on bird and echelon. Rightio. So we're going to do something different, which is we're going to get rid of these these blue delays down here, and we're going to show you what like for like is. So I'm not going to get rid of those first ones there. Actually, I'll click over here and we'll go down here. Yeah, like this. I want those two there, so doesn't really matter. And we're going to clear those delays. Alright, so now we have a pretty patchy. Now we did have a 2567 offset. Now we're going to do what was termed when I was a shop firer back in the day, which is, well, I'm still a shop firer, but back when I was on the bench doing this daily, we would call this train tracks, and you would use this to do various things. So train tracks is simply we're just going to use our shorter delay. So let's say you've run out of 67s, nobody ordered them, the engineer didn't order them, or the drill and blast supervisor didn't order them, or someone essentially just left you in the lurch. You fly in, they've given you a 2567 echelon timing, and you don't have any 67s. You only got 5 or 6 left in the magazine. All right, so we're going to head off through here with 25s. All right, let me just get back there because that was pretty stupid. And so we are just going to drag this out like this, and this is like for like. This is the same timing construct, and that we saw just before. It's exactly the same because our relationship is 2567. So now we have a 2567 in our little timing triangle. I like to call them timing triangles. It's a good way to see wherever you are. So in this timing triangle at 100, you can expect the next hole to be 25 and this next hole to be 67 difference, which is 192. So if you just drop the 1 off the front here, you can see that they're exactly the same. 0, 25, 92, 0, 25, 92. Pretty easy, I think. So this is a what I call a timing triangle, when you're just looking at this little box in here, this little box through here. That's a timing triangle. So those holes relate to each other in a similar fashion, and that timing triangle is there and replicated throughout the entire pattern because this is a pattern, and consistency is a way to understand things. So pretty easy, I think. So we can see here now, how do we know this is the same? Well, let's look at our analysis, and we can see our, let's drop this down to 25. Don't know why it's there. I'm going to get rid of this tags business. Yeah, so we can see here this timing is very similar, or it's exactly the same. So I'm going to save this one as train tracks, and we can then look between the two. Where was I? This echelon, so I'm going to call this traditional Shocktube train tracks. Now it's not you'll hear people say this is not a good practice, and they're quite right in saying that it's not a good practice to do train tracks. But when you're in a situation, it's a fairly reasonable. It's fairly reasonable to do this if you need to do this in order to do your job. There is risk associated. If one of these, generally with an echelon, if one of these holes perhaps is a misfire, one of these lines, then you end up cutting off on an echelon. Whereas if one of these holes is a misfire in here, one of these lines is a timing lines is a misfire, these shock tube lines, then you end up firing over the top of it because it comes along this path. Yep. So we have done our traditional train tracks. We will get rid of this one here, and we'll get rid of this one here. So I think so. I'll save it. I don't know why it wasn't saved. So where are we? Well, here we'll get this traditional Shocktube echelon in, and we're looking at the same sort of stuff. I get back here to the train tracks, and if I turn on the echelon, my goodness. There you go. So right now you can see that this is exactly the same. We're at 543 is our largest delay on the traditional Shocktube echelon, and 543 is our longest delay, or our longest firing period on our train tracks. So just between the two of these, you can see that they are exactly the same. I think this is a really good concept to master what's the same and what's different. Now let's do an extreme difference, I guess. Where would we be? Doesn't really work out with this timing construct as much as what I was expecting. But let's see what we can do. This is 92 between this one. Yeah. Now I was hoping to do something quite odd, and I'll have to think about that. Let's have a little think about this here, and I might just see what we can do here. So I wonder if I can do this manually and change this to a 17 and see what happens with the recalculation. Well, that didn't really suit my requirements at all. Yeah, that's a terrible thing to happen. So we'll delete these. Just trying to think about what's our options. Let's just delete all these. All right, we're going to do something a little bit different here. I've just decided what I'm going to do to show this point of how you can get around certain things and how you can use things that don't look like you're used to do something functional with it on a blast. Now, you know, these days a lot of people are using electronics because they've been told that electronics are the best things to use, and that they're very flexible. I must admit they're very flexible, but something about Nonel is it's cheap, it's effective, it's reliable. So I don't think there's too much of an issue using electrics, or sorry, non-electrics or Shocktube. Right, so let's do this with, we're going to do a 2542. Let's see what it looks like. I think that's what I want to do, because that's going to show us really something there. That's terrible. Yep, okay. Radio. Stupid zoom. And so we've got 25, and we're going to hit with 42s coming back. 42s, radio. Yeah, this is exactly what I wanted to show everyone. So we've got a 42 sort of like 42 going this way, 25 going this way. That's fine. Let's just edit this whole delay to be 0 so we can, yeah, and we will drag this up. This is good. I'm doing a terrible job of controlling my screen, but I'm sure you'll forgive me. Well, all 0 of my watches, I think. Anyway. Actually, not going to do anything with that one. We'll have to change that, so hopefully we'll just edit this whole delay, or yeah, delete that whole delay. We'll hit this 25 back again, and hit this 42 up here. Now I found that on that conversation piece around electronics and non-electrics or shock tube delays, I often find there's a perception that anything is possible with electronics, like you can break all the rules, but you still are limited to time, and time's a very classical mechanical concept in the fact that time doesn't change. Time is a millisecond is a millisecond. Well, within our scope, obviously if you're doing things at the speed of light, it changes. Anyway, so we've got this 25, 42 construct. Seems pretty reasonable to look at that, and then I think what we're going to do is show you the relationship of this. So you can see here that we've got a couple of odd bits. Let's say you run out of, let's say we run out of 42s. Let's say we run out of 42s right here. So we're going to get rid of all the 42s, and we've only got a few 42s. So we're going to do the exact same thing as what we did before, what I showed before. And we will drag this out this way. I'm just going to show you what the same looks like for that situation. Delay selection, clear the delays. Rightio. So we have cleared those delays, and we only had four. Let's say we had 3 42s in the magazine. There you go. We'll use that. Actually, we'll do what I said first off. We've got 4 42s in the magazine, and we use them, and we're going to drag that up through there. But anyway, before we do that, we're going to string in our 25s. We say, oh, well, I've only got this many 25s. Cool. Really getting annoyed with that, so I might just zoom it out. There you go. And grab our 42 up here, and our 25 going this way. And so this is what we've got in the magazine right here. This is the same as what we just saw, exactly the same. Nothing's changed here. We want to keep our eye on this 443 because that will give us a good indication of whether something changes in the pattern. 443 is the number we're looking for. And we will we'll do something else now. We're going to say, oh, well, I ran out of 42s, let's say. Let's actually make this a real mess. So this line here, 292, we can, this is what our end point should be. So we're going to do this, functions. Clear these delays, right? And I'm going to say, well, I've only got, let's say I find a few more 42s. Okay, how do I find a few more 42s? Right here. Oh, look, boss, I found these extra 42s. Hopefully no one makes too much noise down there. I'll probably have to end this stream anyway very soon. and maybe someone will find this stream useful. Alrighty, so 292, that's exactly the same. So obviously we've gone up here and now time has ended up that path is all the same. So then you go, okay, well, maybe we have a problem here, and we don't have this delay here. So let's just select that one there, and we'll delete that. And we've run out of 42s. So something weird's happened. You run out of 42s. Okay. So what can we do? Well, let's see what we've got. Well, we've got these delays. Radio. What have we got? We've got 67 and 109s in the mags. Okay, what shall we do? Radio. So well, I might do a 67 back through here, because we can see here our timing triangle says that 0, 67 is a relationship that we know about. And this is how it should be in this area, is 0, 25, 42 coming back to a 67. So we will go with 67 through here, if I get it right. Oh my goodness me. There we go. I've already got a connection there. Maybe it's not going to like it because this doesn't like double up connections. So what I'll do here is select this one here and get rid of this one delay. Alrighty, so now I can probably get that 67 on there and it will work. Yep, there it is, and we can see that the timing is being consistent. So now we've gone back with a 67. Now this is some people will know this as a zigzag through here, and let's say we run out of 42s. This is an offset. Oh, what a terrible job I did there. This is an offset 42. So let's say we've got that there. That's right, I deleted a hole like an idiot. Okay, let's get rid of this 42 only. Right, grab this, we'll put that 67 in there. First of all, we'll have to get rid of our 25, and we'll our timing window back up, 67, we'll put that back in here. And then, so it's all the same. Everything's the same. What do you mean? Nothing different. So we're all the same now. Because we only had certain number of debts that we could use, certain number of service connectors that we had. So then how do we get this? Well, we're going to run a line up, and hopefully maybe we could splice them. I wouldn't recommend splicing service connectors unless you absolutely have to. They are a key way to get misfires, just because people often don't pay attention to what they're doing when they're doing it. They're in a rush when they're splicing. However, we could, or let's say, well, this is a 6x7, so let's say we have 15 meter leads, because we often have drillers that drill not in the right location. This is all really old school. This is sort of like the stuff that I had to deal with, and we'll time that through there. And you can see here that this mess is exactly the same as a 2542 echeloned offset, echeloned blast. I just wanted to point out that you can do a lot of really funky things with your timing that you wouldn't normally think about, because your brain's potentially not thinking about these relationships. But I do this all the time. But if you are thinking about these relationships, then you can do some really cool troubleshooting, some really cool fixing, and capture a lot of information, and still get the exact same result. Now, if you handed this to your supervisor and they went, "What sort of crap is this?" then they'd be right. What sort of crap is it? Because it's not consistent, and it's quite confusing, and there's probably a whole bunch of people that would get confused about it on the shot. But you know, you mark it out, it's the same numbers. They're all the same numbers. Anyway, I thought this was a first time go at well, a first time go at streaming, and I thought that I would give it all a shot and see how you guys, whether you like this sort of video, whether people want to join in streams, what sort of time that they would want to ask questions. They could probably ask me questions and I would try to answer them the best way I could, or perhaps they could even educate me and give me a good run for my money and teach me a few things. That'd be great, and I could teach you a few things. Anyway, I hope you like this stream. I'll see what response it gets on the YouTubes, and take care, look after yourselves, don't discriminate against anyone, and yeah, that's about it. So thanks for watching if you did watch it.